Welcome back. Today we're not really just talking about math. We're talking about the fundamental language of our entire 2D world. It's the code, the DNA that builds everything from video games to massive architectural plans. So let's create a blueprint for straight lines. I mean, think about it. How does your GPS figure out the absolute shortest route in like a split second? Or how does a game engine render a perfectly straight, crisp laser beam instantly? Well, the answer to both is actually pretty elegant. It all boils down to one simple, fundamental idea: the straight line. This isn't just about drawing. This is the algebra that lets us control and build our 2D world. Okay, let's dive in. Here's our game plan for today. We're going to start with the blueprint itself, then grab our measuring tools. After that, we'll define our main drawing tool, the straight line. Then we'll actually construct some shapes. And finally, we'll look at some of the advanced strategies the pros use. First up, the coordinate blueprint. Look, before you can build anything, you've got to lay the foundation. And in coordinate geometry, that foundation is absolutely everything. And that foundation is the Cartesian plane. The best way to think about it is like a universal grid, kind of like a piece of graph paper that stretches out to infinity. It's got two main lines, the x and y axes, that let us give a unique address, we call it P of xy, to literally any point in space. This simple idea is the magic key that lets us turn geometry into algebra. So our blueprint is all laid out. Now we need our tools. And we're going to start with the architect's most basic but most essential tool, the measuring tape. What's really cool here is that we basically have two main ways to measure. Over on the left, the distance formula does exactly what it says. It gives you the exact length between any 2 points. It's like pulling your tape measure from one end to the other. But on the right, the section formula is a bit more clever. It helps us find the exact address of a point that cuts a line in a specific ratio, kind of like marking a spot exactly 2/3 of the way down a piece of wood. Both are super important. Okay, we can place points and we can measure the distance between them. Now it's time to pick up our main drawing tool, the straight edge. Let's figure out how to define a straight line using algebra. The single most important thing about any line is its slope, or what some people call its gradient. It's just a number that tells you how steep it is. It's calculated using some trigonometry, the tangent of the angle it makes with the x-axis, which in plain English just tells you how much it goes up for every step it takes to the side. The slope really is the DNA of the line. It tells you everything about its direction. And here's the thing. A straight line isn't a one-size-fits-all situation. Depending on what info you start with, you'll use a different equation. Think of these like different grips on your tool. If you have 2 points, boom, use the 2-point form. If you know the steepness and where it crosses the vertical axis, the slope-intercept form is your best friend. Know where it crosses both axes? Go for the intercept form. And for some trickier problems, you've even got this normal form. Each one is perfect for a different job. Right, so we have our lines, the architect's favorite drawing tool. Now we can start putting them together. We're going to move from just drawing lines to creating actual designs. And the most basic shape in any blueprint is, of course, the triangle. Now, inside any triangle, there are these 4 special centers that act like critical hubs. First, there's the centroid. That's the triangle's center of gravity, where the lines connecting corners to the middle of the opposite sides all meet. Then you've got the incenter, which is the center of a circle that fits perfectly inside the triangle. There's also the orthocenter, where all the altitudes meet. And finally, the circumcenter, which is the center of a circle that passes through all 3 corners of the triangle. Knowing these is key for solving really complex problems. Now listen up, because this is a pro tip, a golden rule that connects 3 of those special points. For any triangle, it doesn't matter what shape, the orthocenter, the centroid, and the circumcenter all lie on the exact same straight line. And what's more, the centroid always splits that line in a perfect 2-to-1 ratio. This isn't just some trivia, it's a huge shortcut that can save you so much time on an exam. All right, we have covered the fundamentals. You've got the core toolkit. Now, let's open up the advanced toolbox and look at the pro-level techniques that solve the really complex designs super efficiently. So, picture this. You have 2 lines, and they cross at one single point. Now, what if you need the equation for every single possible line that could pass through that one point? I mean, it sounds like an infinite problem, doesn't it? Well, the solution is just beautiful. It's a concept called the family of straight lines. If L1 and L2 are our 2 original lines, we can combine them into this one master equation. By just changing the value of that one number, lambda, you can generate every single line that passes through their intersection. It works because any point that makes L1 and L2 0 has to make this whole thing 0 too. It's an absolutely brilliant shortcut. And for our final pro tool, we've got something called homogenization. Now, the math can get a little heavy here, but just think of it as a special tool. It lets you look at where a straight line cuts through a curve, and it instantly spits out the equation for the two lines that connect the center of our grid, the origin, to those exact intersection points. It's a very specific tool for a very tricky job, but man, when you need it, it's a lifesaver. So there you have it. From the basic grid all the way to the most advanced strategies, you now have the complete architect's toolkit for working with straight lines. The only question left is, the next time you face a complex problem, are you going to be able to see the blueprint hidden inside?